Okay, welcome back. In this one we're going to look at plotting the graph of a line in the plane. So, in the last one we looked at plotting points. So now we're going to be looking at a linear equation. We're going to be substituting in some x values. It's going to give us the corresponding y values for each individual x, and then we will plot those in the number plane, and hopefully they will all fall on a nice straight line. So what I've done is I've photocopied the example in the book, so hopefully this will save a bit of time. Essentially with these graphs, so we've got like a table and an equation. So this is the 2.2, so you know where we're looking. So we'll just do this first one. So our equation is y equals 2x, let's write it a bit bigger, 2x plus 1. So what we're going to do is we're going to take the x values 0, 1, 2 and 3, substitute them in here into this equation. We're going to evaluate what each of those values gives us as our corresponding y, and then that will allow us to generate a series of coordinates that, well, we'll see when we get there. Okay, so the easiest way I think to do this is to understand that this is 2 multiplied by the x value that we're going to substitute in, plus 1. So the way I normally would fill out this table, in the working out part, I would write this equation with a set of brackets where I'm going to substitute in the x value. I would write it like that, because here is where we're going to substitute in these values for x. So what I'm going to do is I'm going to write this out in each of these spaces. Like that, and then in a different colour just so you can see what's going on, I'm going to put these x values into the brackets. So the first one is 0, 1, 2, 3. So now to work out what y is going to equal for each of those substituted values, we just need to work out this sum. So 2 multiplied by 0 is 0, plus 1, 0 plus 1 is 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. And 2 times 3 is 6, plus 1 is 7. So I hope you notice that there's a bit of a pattern forming. These are all the odd numbers. So we've substituted in 0, 1, 2, 3, and our equation has given us 1, 3, 5, 7. So in this final column where it says point, or maybe it might say coordinate, we're going to write out our coordinates first with our x and then with our y. So this one would be 0, 1, 1, 3, 2, 5, 3, 7. So we've substituted in a range of values for x, and it's generated corresponding y values based on this equation, and that has allowed us to combine those, the number we plugged in and the number we got out, as a coordinate. So now that's the maths bit. So now we're going to plot these points onto this graph. So something that's really important to do is to number the scale. So 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9. So you don't necessarily have to number every space, but as long as you keep your scale regular. So it's just like a graph. So the first one, 0, 1. So 0 is essentially on the y-axis because we've moved 0 spaces in the x direction. And then 1 is there. I'll try and make them visible. The next one, 1, 3. So we come along 1 and we go up 1, 2, 3. The next one, 2, 5. So we come along to 1, 2, and then we go up 1, 2, 3, 4, 5. And I'm hoping you'll notice that these are all landing on a straight line. And then the last one, 3, 7. So we go 1, 2, 3. We go up 1, 2, 3, 4, 5, 6, 7. And it is there. So the last thing, because this is essentially linear modelling, we are dealing with points on a line. The last thing to do is pull out a ruler and rule a line through those points. There we go. So that's all you need to do. Cool. Right, so I'll do the second example, and all that's really different is instead of starting at 0 and just going through positive values of x, we've also got -1 and -2. Can't quite see it, but trust me, -2, -1, 0, 1, 2, 3. So I'm going to do, so this equation here is y equals -2x plus 3. So I'm going to do the same sort of thing. I'm going to write it out as -2, leave some brackets to substitute our x values in, plus 3. So I'm just going to write this out 1, 2, 3, this many times. Same thing in every space. Now, you might be able to do this in your head, but for the purposes of doing assignments and tests, fill out the working out because you get marks for doing this. You get marks for then getting the correct y value, and then you get marks just for writing out the coordinates, as it's essentially copying out the x value and whatever value we get for y. Right, so I've copied out this the right number of times, and now I'm going to, in red again, write in our x values. -2, -1, 0, 1, 2, 3. So now I'm going to do the maths. So it's really important when you're dealing with negative numbers that you don't mess up. Negative times a negative is a positive, and a negative times a positive, or a positive times a negative, gives you a negative answer. Yeah, before I finish this video, I'll talk about what to look out for in case you mix that up. and it should be an indication that you need to just go back and check your working out. Okay, so this first one, -2 times -2 is +4, and then +3 gives us 7, +7. -2 times -1, 1 times 2 is 2, and it's a negative times a negative, so that's positive. So 2 plus 3 gives us 5. -2, lots of 0. Well, 0 times anything is 0. Plus 3 is 3. Can you see that these are decreasing? So -2 times 1, it's a +1, so that's going to give us -2. But then we're adding 3. -2 plus 3 is 1. So here, -2 times +2 is going to give us -4. Then add 3, so the answer is going to be -1. And here, 2 times 3 is 6, but it's going to be -6 plus 3, -3. So we've worked out all the y values. Now I'm just going to, let's do this to save a bit of time. So our first one, we plugged in -2 and we got out 7. -1 and we got 5. 0, 3, 1, 1, 2, -1, 3, -3. Okay, so 1, 2, 3, -1, -2. I don't think we need to go any further. 1, 2, 3, 4. So if we call that 5. 1, 2, 3, 4, 6, 7 at the top. -1, -2, -3, -4. We don't need to go any further than that. Okay, so I might plot these ones in red. So our first point, -2. So we go 1, 2 in the negative direction, and then up 7. 1, 2, 3, 4, 5, 6, 7. So our first point is there. Our next point, -1 in the x direction and up 1, 2, 3, 4, 5 is there. 0 in the x direction, so we're on the y-axis when we plug in 0, and we go up to 1, 2, 3. Our next point is at 1, 1. 1, 2 in the x direction, and then we go down 1. And our last point, 2, 3 in the x direction, 1, 2, 3 in the -3 in the y direction. So they're all on a line, and join them with a line. So that's really all that we need to do. Right, so something to look out for when you're substituting in these values. If you mix up positive times a negative and you accidentally think of the answer as positive, what you will get is, let's just say our line is going, we plot our points like that. When you come to the negative side, you will suddenly start getting something that looks like that. So if you plot either side of the axes and the points aren't falling on a line, either this one maybe should be down here, and that one maybe should be down there, and that one maybe should be here, or it could be a situation, let's just change colour, where these ones need to come down here this way. So if you do your working out and you get your coordinates and you plot them and you end up with different directions, so they don't necessarily fall on a line, that's an indication that maybe either this side or that side you've multiplied a positive and a negative and accidentally come up with a positive answer. Or maybe you've multiplied a negative and come up with a negative answer. So if this happens, or maybe something like this, then that should be an indication to go back and check your working. Because something either on the left or the right of the y-axis, you've mixed something up. I think that's really all there is to say. So just be mindful of this. If you end up with points that don't necessarily all land on a straight line. Yeah, so as far as doing tests and assignments, make sure you fill out every column of the table. Number your spaces on the axes. If there's no x and y, make sure you label those. And once you've plotted all your points, join them all using a ruler. Needs to be a nice straight line. Okay, I think we'll just stop that one there. That's probably all we need to say. See you in the next video.